This is the Earth Science Classroom. Welcome back to the channel. This video is on soil composition. It's part of the soil science unit, and this is an introductory video on what soil is made of, what's in the soil. Now, we don't call this layer dirt. We hold this layer in higher regard than just the word dirt, because soil is an amazing interface and medium between all the spheres on the planet that contains both the biological, the chemical, and the physical processes all in one thin layer right on the Earth's crust that is created with a mixture of weathered material and organic components, all mixed together with air and water. So this video is looking at what is in our soil. So we've got this little pie chart here that's going to break down in the percentage of what is in the soil. So you can see you've got this large component which is minerals, around 45 to 50%, so range. All these are averages, but they can change based on the soil type, the soil location and climate, but the generic numbers are presented here. So minerals can range between 45 and 50%. The empty space in between the soil particles and the organic particles, that is the vacuum, the airspace, and then between that as well you have water, so it fills up the pore spaces. So air and water are combined pore spaces, which is the space in between the physical components of the soil. And then you've got a small amount which can vary between 0 and 10%, which is basically organic, and it can be broken down into humus, roots, and basic organisms, and how this can combine into a organic mixture and component of the soil. So if we start with the largest component, minerals, that's the physical, solid, unconsolidated rock part of the soil. And the minerals we know make up rock, and there are around 4,000 different minerals, and all make up different types of rocks in the three main categories: igneous, metamorphic, and sedimentary. Now, most of the bedrock which the soil is derived from or transported from is going to be sedimentary. There might be some small amount of metamorphic and small amount of igneous, but majority is sedimentary. So you'll have those classic sedimentary minerals that are in the rock that are now part of the soil, that make up the soil. So you have different sizes of grain size or sediment within the minerals, and the smallest one is clay, which is very, very small, tiny particles, around 0.002 millimeters in diameter. The next one is silt, again very small, but the next size up. Then sand is the largest of the small fine particles, which is 0.05 to 2 millimeters in diameter. Then we get the larger particles, the larger bits of rock, things like gravel and pebbles, which is up to 64 or 6.4 centimeters. Then we get the cobbles and stones, the larger pieces of rock or pieces of minerals combined. They're between 64 or 6.4 centimeters to 25 centimeters. Then we get the boulders, the large rocks that are in the soil, in the ground, which is anything over 25.6 centimeters or 256 millimeters, which is classified as boulders. Now, all of these can mix in with the soil, but that's the largest component. Then we get the biological, up to 10% of the soil. The biological component, the organic component, is very important. You have the living part of the biosphere, the plants, vegetation, shrubs, all that living component is going to add the root systems and add stability and add life and nutrients and water to the soil. Then you have the decomposing, the dead part of it. So when the plants and vegetation die and decompose, there are organisms or microorganisms that are in the soil that are going to break down, decomposers and bacteria are going to break down this organic material into nutrients, and this turns into humus. Now, humus is around 4 to 5% of the organic material, and it comes in both macroscopic, the larger particles, and also the microscopic. And this is what helps to develop our biosphere. Now, a little point on humus right there. Even though it's a small amount, humus is very important. It's that dead, decaying part of the organic material that's gone through the soil, and it can also be leached down into deeper layers or horizons of the soil But the humus does many or has many benefits for the soil, which is increases the water capacity. It also is a reservoir, a trap, a sink for nutrients that have been taken out from the organic material through the microorganisms through decomposition and collected in this dead organic matter. And then it can also, as a follow-on, can provide those nutrients to create a more fertile soil and create a more or larger or thicker organic layer, which is called the O horizon, and also can leach and percolate down and reach deeper into the A horizon and even possibly into the B horizon. This all accounts for a more fertile soil, able to grow more crops, vegetation, forests, and can provide a more stable soil for vegetation to grow. Finally, we have the pore space, which combined could be up to half of the soil. So half the soil could be just empty space filled with either water or just basic air and gases. Now, you can get saturated water, saturated soil, which has more % of water and less air. Depends on the climate and the location. But the pore spaces combined equal that empty space in between the physical minerals and rock component. Now, this can play a very good part in terms of aerating the soil, having nutrients in the soil, having space for the roots to move through and stabilize the soil. And you have the mixture of rock, air, and organic material making up soil. This is the Earth Science Classroom. Thank you for watching. I hope you enjoyed the content. Check out more videos on our channel and don't forget to subscribe. Thank you again.